Hello everyone and welcome to Thinking with Mathematical Models 4.2. Our learning target today is I will examine the relationship between two variables and develop an understanding of negative correlation. And what negative correlation means as one variable goes up, the other variable goes down. Okay, so we have a downward sloping line. That is a negative correlation. Our ACEs for 4.2 begin on page 98, and they are problems 4, 5, 17, and 18. Page 85 in your book, older and faster. This is a negative correlation for 4.2. Tells us Magnolia Elementary is a school with students who are 5 to 14 years old, and they're going to run a 100-meter race. They get timed in. They give us a table here, shows us those results. Okay, has the students' ages here and their race time. And what they've done is they've taken this data from this table and gone ahead and graphed it out over here in this scatter plot. And it asks us a few questions. It says, how would you describe the relationship between age and race time? So as age increases, what's happening to our race time? And then, do you think that this relationship is strong or weak? As in, are most of the points on the scatter plot close to the line, or are they further away? And are they, as I just said, are they close to the line, or are they spread out further away? That's going to help determine your strength and weakness of that line. So part A, using the race and time and age graph. So we're just using this graph. It says, what is the approximate slope of the line? Well, a reminder that slope equals rise over run. Now, I want you to pay attention to the scale, because along the x-axis we increase by 2 each time, but along the y-axis we increase by 5. So to find your slope, we need 2 points along the line. Pick any 2 points, but make sure you're paying attention to what values they are, because going 2 this way gives you a value of 4, going 2 this way gives you a value of 10. So pay attention to that scale. Then it says, how does the slope help you understand the relationship between age and race time? So every 1 year change in age, their race time should change by what? That is a real life application of using unit rates, okay? Part 3, do you think it makes sense to predict a race time for a 7-year-old student using the line? So we have this line. Would it make sense to be able to predict the time of the race for a 7-year-old? If so, what would you predict for that 7-year-old, and how confident are you in that prediction? Then part 4 asks us if, using this graph, could we predict a race time for a 21-year-old? If so, what would you predict, and how confident are you in that prediction? Then part B, we're just going to do 1 and 2. It says find 2 points that don't really seem to fit this model. So of all of these scatter plot points, find 2 of them that you don't think really fit the model of the straight line that we have here. What are their coordinates? Okay, and then why do you think the points that don't match the overall pattern? What real life situation might be happening that would make these not fit the overall pattern? And let's see, next for C, we have a different table. This is for students at Magnolia High School and relating their age and their GPA. So their age is along the x-axis here, the y is down here for their GPA, and so they've graphed this scatter plot here. Do you think that age and GPA are strongly related for these students? Why or why not? How is your answer in part 1 supported by this table? And how is your answer in part 1 supported by this scatter plot? So those are some inverse correlation things that we need to take a look at, and then we need to also determine whether we can find strong patterns amongst our scatter plots by being able to draw lines of best fit. Whereas in the first one, pretty good line of best fit. This second one here between GPA and age, maybe that's going to be a little more difficult. Reminder again, our ACEs for 4.2 are 4 and 5 and 17 and 18. Let me know what questions or stuck points you have in class. Look forward to seeing you then.